Welcome to the final video for Chapter 11, and this should be a pretty quick video. What we're going to be generally discussing here is something called a Laffer curve, which I can't remember if they discussed this in Chapter 11 of the book or not. I know it's discussed in the book, but I'm not sure if it's in Chapter 11. So this is a case where the video is definitely going to be more helpful than the book. But a Laffer curve is a very general economic concept that you should be able to find a lot of information on, online. On YouTube, things like that. So a Laffer curve we're going to get to. But first, to introduce you to this topic, I want to show you an example. Let's imagine there is a parking deck in Athens, in a crowded area of downtown Athens where a lot of cars and a lot of people want to park. And let's think about the different fees that the city could charge. Okay? If they charged no fee, they would get 200 cars to park, and they would thus generate no revenue, right? If they're not charging the cars to park, they're not going to generate any revenues. Maybe in this scenario, there's 500 cars where the drivers would like to park in the deck, but they're just full, right? They're full. So no revenues would be generated here. If you go to a $1 fee, maybe that causes some people to not want to park in the car deck, but there's still plenty of demand. There's still plenty of people that want to park there, so it still fills up. But now, since they're charging $1, they generate $200 in revenues. Okay? Well, what you'll see is as the price goes up, eventually you start losing some of these drivers. So once the fee goes to $2, you'll only have 180 drivers, causing revenues to rise to 360. Okay, so maybe some of these drivers now, decide not to go downtown. Maybe they decide to take an Uber instead. Maybe they figure out some other place to park and then they walk a half mile to downtown, perhaps. When the cars park goes to 100, they're now going to generate $500 in revenue. But what you'll notice is eventually the fees get so high that the revenues actually start to go down. And eventually the fees could be so high that no one parks there. So maybe they generate no revenue. This is not an unbelievable concept, right? This is a concept that makes a lot of sense. The basic logic here is when the fees rise for anything, such as a parking deck, revenues will rise at first, but eventually the fees will be so high that the revenues begin to decline. What made me think about this example is I have a friend, he's an economist at Kennesaw State, and they have a parking deck, I think it's in downtown Kennesaw. I know it's somewhere up in that area. And they actually had the problem where they were charging $5 fees and nobody was parking there. And he was basically saying that this was idiotic and they should actually lower the fees to get more people to park, which would actually drive up revenues. The point being made is that increasing your fee doesn't always lead to more revenues because you lose customers in the process. Ultimately, what ends up happening then if we wanted to graph this relationship between the revenues and fees is pretty interesting. Without dealing with specific values here, what you would see is essentially that as the fees go up, the revenues rise at first, but then eventually start to decline. Okay, and that's what you're seeing here. The revenues go up and then eventually start to decline. If we have no fee, all right, down here, if we have no fee, then we're going to earn no revenues. And also if the fee gets large enough, right, maybe in this case, maybe it's at $30 where you lose all your customers. Okay, so anything above 30 will get you no cars. Eventually you get to the point where the $30 fee also generates no revenues. Okay. And the reason why the upward effect and the downward effect happen is because there's two conflicting things that are occurring. Revenues is equal to the price or the fee times the quantity. Right? Any type of revenues you're talking about, you can solve for by taking price and multiplying it times the quantity. So in this case, price being the parking fee. And there's two effects. When the price goes up, ceteris paribus, that leads to more revenues, right? More price, more revenues. But we know ceteris paribus isn't true in the real world. The other thing that may happen is when price goes up, that may actually cause quantity to go down, which could cause revenues to go down. So we've got two conflicting things occurring here. When price goes up, that ceteris paribus causes revenues to go up. But when price goes up, that may drive quantity down, which could drive revenues down. So you've got two conflicting forces here, okay? This, by the way, is not a Laffer curve. This is just an introduction. Now I'm going to show you what the Laffer curve looks like. The Laffer curve is basically the same general concept applied to taxes, okay? And so what I showed you, I guess, in a way is like a Laffer curve, but it's a little different from the way we would normally set things up, okay? Laffer curve usually deal with tax rates, okay? So let's imagine here are our scenarios. Let's focus on an income tax system. And let's think about tax rates at a few different levels here. Okay, and let's let this be our effective tax rate. In fact, I'm going to go ahead and relabel this the ETR, the effective tax rate. And so this shows what percent of your income goes towards the tax. And we're talking about income tax systems here. So let's think about what would happen. If there is no effective tax rate, is that a good or a bad thing? Well, it depends on your view. It's really good for the workers that don't have to pay the tax, but it's bad in the sense that we don't get any revenues out of it. So it's a good thing and a bad thing, okay? Now let's think about a 100% tax rate. Good thing or a bad thing? You may be tempted to say, well, this is bad for the workers but good for the government. But think about it. If there's a 100% effective tax rate, would you earn any money? Would you try to work? That means the government's taking every penny of what you earn. I wouldn't work, right? I wouldn't work at an effective tax rate of 100%. I might not even work at an effective tax rate of 80%. Essentially, if the government takes all of my money, I've got no incentive, okay? So kind of like having a high parking fee, a high effective tax rate is going to keep people from engaging in the activity. So if we think about the incomes in a society, and this is just to use real simple numbers to give the example, what you might see is as the incomes go up, you start to lose some workers. And that might be how your incomes are set up, okay? The higher the effective tax rate, the fewer workers are going to work, and so the lower income tax incomes you get. Essentially, when the effective tax rate gets high enough, you're losing a lot of workers who say, it's not worth it for me to work if I'm not going to be taking home much of my income, okay? The tax revenue then can be solved by multiplying the income times the tax rate. Starting at a 0% tax rate, we get no tax revenue, okay? That's a bad thing, but the good thing is the workers are getting a lot of income, okay? So it's not all bad. Some good and some bad from that. As your effective tax rate goes up, you're going to start generating more revenues. All right, so I'm just taking 9,000 times 20%. You get 1,800 in tax revenues. Jumping to 40%, you get 2,400 in tax revenues. At 60%, you get 3,000. At 80%, you'd be back to 2,400. And with a 100% effective tax rate, you'd end up with no revenues. Okay? The person who designed the basic graph that I'm about to show, his name was Art Laffer. Art Laffer, okay, that was his real name. He was an economist, and it's kind of an interesting story. He was at a bar discussing some economics with just some other econ people, and he took a bar napkin and he drew a graph, and he was basically just saying, look, when income taxes go up, when the rates go up, revenues might actually go down, and he was showing this on a graph. He ended up being a chief economic advisor for Ronald Reagan, and Ronald Reagan actually modeled a lot of his tax policies based on Art Laffer. Ronald Reagan basically said, look, if we lower tax rates, we may actually get more revenue. Because he thought, perhaps we're here. Perhaps we're at a rate like 80% in this example. So if we lower our rate, maybe we'll actually get more revenue. Okay? That was his argument. So what Art Laffer basically did was he took this graph and turned it into a Laffer curve. All right, so this is your first true Laffer curve here. And it's a graph that shows the tax rate and its relationship with the tax revenue. I'm going to define it down here just so I'm being very clear. It can be applied to any tax, any type of tax rate. But I'm choosing income taxes because, as we said in the last video, income taxes is the number one source of government revenues. So it's a really important system, and a system that we think a lot about. I mean, I pay tens of thousands of dollars in income taxes every year. So this is an important issue to anyone in the United States. So using these specific numbers that we have up here, I'm going to just plug these in. Okay, well, these are our tax rates and our revenues. I'm just going to kind of scale these here. Economics, we don't really care that much about using real numbers when we're discussing an issue like this. The reason being that it's often hard to get true data. In other words, think about what it would mean to get these data, how hard it would be. You would actually have to go in and change tax rates a bunch. Try it, see what happens if you put it at 80%. Then go to 20% and see what happens. That's a very costly experiment to do in the real world because you'd be affecting people's lives tremendously. So we also don't deal with real numbers because real numbers are not usable. We can't collect real numbers. So I'm going to use real numbers this time, but in the future, if we come back to this, I'm just going to generically just think about the shape of the curve. Okay, so this first time, let's think about it in terms of some numbers. All right, if we have no tax rate, which I really should include down here too, since that's one of our data points, 0% tax rate. If we have a 0% tax rate, we'll earn no tax revenue, which would be a point here. If we have a 20% effective tax rate, we'll earn $1,800 in tax revenues, which is a point roughly right there. At a 40% tax rate, we'll earn $2,400, which is about right there. 60% effective tax rate, $3,000. 80% tax rate, $2,400 again. And if we get to 100% tax rate, there's no incentive to work, so no one's going to work, and the government won't be able to collect any tax revenue because there is no income. And so we'll be back here at a 0% or $0 tax revenue. Okay? Connecting the points here would end up looking something like this, okay? And it doesn't have to be uniform. It doesn't have to be just perfectly, up and then down. But the point is there's an up portion and then there's a down portion. There's an up portion because of basically what's happening is the effective tax rate is winning out. We're losing some workers, but the effective tax rate, that effect is bigger than the effect of losing workers. But eventually we hit an inflection point here and it starts to decrease. And what's occurring here is we're losing so many workers that the benefit from the effective tax rate is overwhelmed by the fact that we have fewer workers. So it starts to decline. So that's in general what a Laffer curve looks like. And all Art Laffer was basically saying is, if the government needs tax revenues, it shouldn't blindly just say, let's raise rates. Okay? Let me say that again. Art Laffer has basically presented this just to be very careful, just to caution the government. If we need to generate more revenue, raising tax rates might not necessarily do that. Okay? If we're at a tax rate of 80%, for example, raising the rate further would decrease revenues. And in some cases, perhaps going from 20 to 25% could do the same thing, could also lead to less revenues. All right? It just depends on the exact shape of this graph. So let me erase this and let's see what else we can learn from this graph. we'll stick with income tax just because income taxes are important, but it can apply to anything. And a 10% tax rate could be really important for certain items, for example. All right, so here's tax rate, here's tax revenue. Maybe it looks like this. Okay, this still fits what you normally see with a Laffer curve. All right, and maybe that pinnacle there is at 35%, for example. Let's think about what we can learn from this Laffer curve. Okay, so for example, one question I often ask my students is, what is the best rate? What would be the best rate in this system? And the tempting thing is to look up here and say a 35% tax rate is best. But that's not the case, okay? A 35% tax rate maximizes revenue. But that is still going to drive some workers away, okay? A 35% tax rate would maximize revenue, but people have to pay 35% tax, which is a lot. To put this in a term that maybe is easier to understand, maybe a tuition fee of $20,000 a year would be best for Georgia College. Maybe that would maximize revenue. But revenue isn't our only goal, right? Our goal is student quality and making our students happy, et cetera, et cetera, et cetera. So maybe $5,000 a year would be better. Okay? Maximizing revenue is not the only goal. Because even at a 35% tax rate, there will be some people who choose not to work. Okay? All this does is maximize revenue. It's not necessarily the best. To give you an example of what I mean by that, maybe in more clear terms, compare point A versus point B. What's good about A? More revenue. More revenue is good because we can use the revenue for government services. But what's good about B? At B, you'll get more income and more take-home income. Right? What I mean by this is more income in terms of there will be more people working. There will be more income earned. And furthermore, the people who are working will take home more. So if I'm earning $100,000 a year, I'm going to take home more at B than I will at A. Great for me. Also, there's some people who might say, look, if the tax rate goes to 35%, I'm going to stop working entirely. So these people are also going to be better off if we're at point B. Okay? So we can't compare A and B and say which one is definitely better. We would have to be very specific and decide what our criteria are. Okay? So points like A, B, and even C could all be, each of those could be best. Maybe no tax rate is best because then we'll get a lot of people working. It just depends on what you care about. So we can't tell which of these points are better. But we can tell something from these graphs. Let's think about point C, for example. Or I'm sorry, we already used C. Let's call this point D. If we compare point D to point A, or to point B rather, B and D have the same revenue. But B has a lower tax rate. So B is better, period. B is better than D, period. There's nothing to argue about, okay? Because they're tied in terms of revenue, but B is going to make people a lot happier. Furthermore, A is definitely better than D. A generates more revenue and at a lower tax rate. So we can't compare C, B, and A and unequivocally say which of these points are best. But we know D is bad. And we know E is bad. All right? There's a point over here we could compare it to and say, look, point F has the same revenue as E, but F does so at a lower tax rate. G, H, I. In fact, everything over here, everything over to this side of the graph is definitely a bad idea. Okay? So again, we can't tell which of these is better unequivocally. We'd have to decide, what we care about. So we can't just clearly see what's better over here, but we can eliminate all of these options and say all of these options are bad. So the Laffer curve allows us to do some really simple analysis and just think about tax rates, making sure that we're very careful about not making the mistake that think that more rate means more revenue. It's simply not the case. That's That's the end of chapter 11.